I'm CK. This next one's going to be really quick. It's a little bitty power supply, variable power supply for a electronics breadboard. I picked it up from AdaFruit.com. It's designed to work with all the hip and happening new Raspberry Pis, Ada, all that kind of stuff, and also for breadboarding your own components. So just figured I wanted to put it together, see how quick it went together, and see how well it worked. It should work just fine. Hope you enjoy it. Here's a shot of the board again. Nothing too surprising, very small. And as with many of these small kits from AdaFruit or other places like that, you can find a number of them. There's not much to the kit. The parts, no instructions, you just go online to if you really need them. And again, it's adjustable. So let's see, little heat sink, resistors, some capacitors, wiring connector, voltage regulator, a couple of LEDs, a couple of electrolytic caps, some switches, a trimmer pot, an edge connector, which will go, I'm sure, into the breadboard. So let's just slap it all together. And I'm actually going to go through the instructions the way they're listed in the online putting it together. So if you're one thing I really, part of why I want to put these together, and I've got lots of them and we'll go through a bunch of them, is because I think these are important for youngsters learning electronics and technology. And I want to make sure if I see one of these and go through the process of assembling it, see whether I can recommend it to people with younger kids. I got up to check focus and found that my camera battery had died, so you missed putting the power supply connector on, the on-off switch, the safety diode, and now we've put in the one cap, one resistor, and one electrolytic cap. And one thing I was just describing was my personal style, and we all have one that works for us, is I go with component values facing to the left and up, or to the top. So in this case, condenser values, I'm sorry I said condenser, that's because I'm old. Capacitor values face to the left, resistors, the first value stripe, not the tolerance end, but the first value stripe is up or towards the top. Doesn't really matter which way you go as long as you have a way. So you know when you're going back and looking at your work, trying to see if you have to fix anything or if everything's in the right place. If you know, I always do it this way, you know where to look. As I mentioned when you weren't listening, the online instructions are pretty complete. They're pretty good. They're not completely basic. However, they've got a lot of the reminder information and good information available for probably 15 or 16-year-old. If you're a beginner at 11 or 12, you may want to have some more information and somebody giving you a little more help on this. So now we're going to put green LED on. And again, paranoia about polarity keeps you safe and happy. Let's see if I can get it flat. Yep, goes all the way down. Okay, so I'm going to go flip the high voltage end over and solder this up. Let me pull some more solder. I was watching somebody else doing some soldering the other day on a YouTube video. Well, two things, and I'll probably mention this more than once if you watch a number of videos. First, I saw somebody actually, with a soldering iron in his hand, used wire cutters to cut a length of solder to use. He didn't just use a soldering iron. I can't imagine that. The other thing is, I was watching one guy who does guitar amps, and something was bothering me about the way he worked, and I couldn't put my finger on it for a minute or two, and then I realized after each solder connection he made, I heard just a little. What he did is he blew on every connection to cool it off after he soldered it. I mean, that's just crazy. Who does that? It's one of the first things you're ever taught about soldering is you don't blow on the solder, you don't try and cool it off, you let it cool naturally. I'm going to trim off these leads so I have a little more space to finish up. But this guy, I mean, it got to the point where even though he has some good information on his channel, I can't watch him because it's solder, foo, solder, foo, solder, foo, solder, foo. It drives me crazy. I had to stop watching him. I'm sure I have idiosyncrasies that will drive some people crazy also. That one just seemed a little over the top for somebody who does a lot of electronic work. Because having your solder cool naturally is just so much a part of getting good solder joints. Okay, let me trim these up. First, let me take this other arm out of the way. It's just in the way. You know, we always talk about or think about or discuss with our buddies tools, and we do a lot of research on tools. I wore out a pair of flush nippers, these, and went on one of the online retailer sites to get a new one, and I found some relatively inexpensive ones. You know, again, these are pretty simple, and bought, I think it came, these come in 5-packs, and I bought them, not this brand, and it was an off-brand, and God, they were terrible. They were terrible. They wouldn't cut, they wouldn't spring back. After just about 50 wire nips, the edge started to get a little dented, so I went back and got ordered my Plato Model 170s, which I just didn't bother with the last time. Every tool you get affects your quality of life, your quality of work, and spend the money or spend the time to find good tools that suit you. Okay, what does he want me to do next? Oh, we're going to take a break and test the current project. Oh, so at this point, since this is a high voltage side, so to speak, this is ready to test, and the I can't find the power supply I want, so I use this, which is a good power supply. This is a Belker variable power supply. Got all the connectors you could want for different sides. I've just had it as a 9-volt with bare leads on it, but we'll go ahead and set this. This can go, I believe this runs from 6 volts up. So I think this accepts 6 to 12 volts. So I'm going to set it to 6 volts. Come on, thank you. Now I'll find out get the right connector. Again, I normally would just whack this all together, but I'm doing it the way a newbie would be playing with this, so I want to do it in the order that the author recommends. Why is this not going in there? There we go. Okay, so I'll plug this in, and we should get a green LED, and we do. And let's see, what else do we want to see? Check voltage at the V-pad, just to make sure everything is good. Oops. Yep, I'm getting 6.175 volts at that point. So, again, this is a good, I like this. This is a good confidence builder for someone who's new at this stuff, because now they know everything they've done so far is working just fine. Oh no, I touched the electrolytic cap. I'm going to shock myself. Sorry, I'm being facetious. Let's put that away. Go back. Okay. Now we're going to put the voltage regulator in. I want to see how they want to put the heat sink on here. Gosh. Again, he talks a lot in the book, in the online instructions. He talks a lot. Again, that's not bad. Huh. He doesn't actually install the heatsink. Well, there's that. Okay, he doesn't install the heatsink, but he does want the thing up in the air. He indicates, or she indicates, that you should have the regulator up in the air enough so you don't have to clip the ends on the other side of the board, because you have clipped it, you have had it hanging in the air so high. That's an interesting way to do it. Not my preference, but I'll do it the way, again, I'm doing it the way they say. And of course, the way they say also, I'm going to go ahead and solder this right away, because I don't want to bang it and have it come back out. Get my voltmeter out of the way again. Okay, one pin is soldered, which means it's secure. Okay, voltage regulator is in place. Next, so this regulator, this power supply, will be installing a switch here which goes from 3.3 volts, has 3 settings: 3.3 volts, 5 volts, and adjustable. And for the 3.3 and the 5 volts, you'll set the appropriate resistor. So for R3, we'll put a 11K resistor. And it is brown, brown, black, red, brown, even though the last one doesn't matter, of course. Then we'll do R5, which is going to be 6.5 or 6.49. And then the 20.5 kilo ohm. Striping is real bad on this. I'm gonna do like I do out of paranoia sometimes, and check the voltage, the resistance on my meter, because if it's not right, if they put the wrong part in, I've got spares. I probably have one lying around. So that's coming in at 19.95 with really lousy, actually that's pretty good for a brown stripe tolerance, because that's within a couple of percent of 2.5. And my water heater just kicked in, so I'm going to pause the video for a little while. Now we're going to solder in the voltage specifying resistors. Okay, there's the resistors. Turn off these leads. Next is the voltage selector switch. Cute little switch. It's, of course, got stepped pins, so you can't put it in the wrong way. There's a gap. So we'll tuck that in there, and then we'll grab handy dandy locking tweezers to hold it in place. Now I did look ahead, and nowhere in the instructions does the author mention actually installing the heatsink to the voltage regulator, so we'll do that ourselves, maybe. I don't think I'm ever gonna, on a small breadboard, I don't think I'm ever gonna use enough current to heat up the voltage regulator that much, but may as well do it just for completeness. Take the tweezers off now. Oops. I normally don't use this springy thing for soldering, so I usually use a regular circuit board holder, so it's dancing around a little bit more than I'm used to. Okay, switch is installed. Ooh, be careful, it says. Because the solder points are small and somewhat close together, make sure you don't have a short circuit and that each point is soldered. Absolutely, that's why, that's one of the reasons why I don't recommend this particular kit for very beginners or early or 11-year-olds, 10 or 11-year-olds, because it's a little close and they could make mistakes and fail and get frustrated, and there's nothing worse than having your young electronic explorer fail for a dumb reason, like solder points being too close together. You want them to be successful. Reinforce that success. Next diode, checking polarity, because we are polarity paranoiacs. And there we go. All the actual active componentry is now on the board. And the instructions say, let's test it again. So we'll go ahead and test it again. Remove the PCB from the vise and clear off the tape from wire bits. What tape from wire bits? I don't know what that means. We didn't have any tape on any wire bits. Okay, let's plug her in again. Meter in place too. So let's turn power on, and we've got green LED lit, red LED lit. Let's vary the voltage, or went to 5 volts, LED got a little brighter, which is all great, so that is indicating that things seem to be working fine. I'm gonna check the voltage myself. Yeah, I'm getting 5.04 there. If I go to 3.3 volts, I'm getting 3.325. So that's good. And we haven't even put the trimmer in yet. Let's put the trimmer pot in. Last mechanical piece will be the external wire connector. So basic connections are done. Now the next thing we're going to do, so we've got a standard strip, and we'll cut 2 and 2, and we'll see if this breadboard from Makeronics has the spacing right for this connector. Make sure I'm in the camera. Yeah, I am. Make sure I'm in the same line. Why don't I just, instead of putting it in the middle, I'll put it at the end so I know they're in the same line. Jeez, sometimes you have to think and make things easy. Now we'll drop that on there, and yep, pins line up. Great. We solder that in. And we want to glob solder in on this one because there's a lot of mechanical, because it's going to take the stress of being pulled in, pulled out all the time, so we want a lot of metal there. Okay, so that's it. And there you go. So let's see what we got. Let's plug her in again. Plug in. Turn on. Everything's still working. Let me get my trimmer screwdriver. A Heathkit trimmer screwdriver. Some of you will know what that means. Let me do a real quick initial check here. We're set at 3.3 volts. And that's 3.326, which is just dandy. And the polarity is right, which is good. Let me switch to 5 volts. 5 volts, 5.043. That's pretty dang good. Now we'll go variable. And that's at 6. And I can take it up, up, up. Down to 1.2 at the lowest. And it travels all the way up and pegs out at 6. And the instructions say it can go you can take a 6 up from a 6 volt up to a 12 volt power supply to run this. So we're all done and everything works. And it's a handy little mini power supply to plug into a breadboard. The kit's a good quality kit. The components are good. There was no corrosion. There was no flakiness on either the value silk screening or the resistor paint. All looked good. They're all new components. I mean, sometimes you run into stuff that's been pulled off an assembly line as seconds or rejects or extras. But this is all... Oh, I didn't do one thing. Let me do one thing just for completeness. I'm going to check the screw-in leads. And yeah, they're getting the same. Assembly was great for, and again, I'm evaluating this for a young person. Assembly was great, except for, probably for the younger folks, except for the 3 selector leads on the power selector switch. Everything else is spaced up except the voltage regulator is a little close, but that's not too bad because they're staggered. But these 3 leads are a little close. You may want to supervise your young one when they're doing that particular thing. So that's it for this evening. A cute little kit. I will use this as it's better than running wires hither and yon from an external power supply. And I'm going to leave a link to where you can get this in the description. And thanks for watching.